Welcome back to my channel and thanks for being here. In this video, I would like to discuss about the gas turbine engines. So let's get started. Before getting into the topic, let's know the principles behind some of the components with which it would be easier to understand the working of gas turbine engines. Let us first know about the law of conservation of mass. According to this law, mass can neither be created nor be destroyed, but it can be transformed from one form to another. In other words, in an isolated system, the mass entering into the system is equal to the mass leaving the system. And the mass flow is represented by the equation ρ A V, where ρ is the density, A is the area, V is the velocity. So let us consider an isolated system with an inlet and outlet. From this law, mass flowing in is equal to mass flowing out of the system. So we can equate them. And since the density of the fluid remains same on both the sides, we can emit out the density, and hence we are left with A into V is equal to constant, which means area is inversely proportional to velocity. So this plays a major role in the upcoming session. Now let's look at the components on which this principle is being used. The first one is diffuser. It is a device which can reduce the velocity and increase the pressure of the fluid. The shape of the diffuser is mostly a diverging section which helps to increase the flow area. So let's see how it works. As said before, the mass flow rate plays a major role here. Since we are equating the mass flow rate on either sides, we are left out with area into velocity at inlet is equal to area into velocity at outlet. Since the diffuser has a shape in which the area at the inlet is low and the area at the outlet is high, the velocity at the inlet must be higher and the velocity at the outlet must be lower. Only in this case the mass flow rate remains same. So this is the principle behind the working of diffuser. Since the velocity is high at the inlet, the pressure will be low according to the Bernoulli's theorem, and the pressure will be higher at the outlet of the diffuser. Similarly, we have the nozzle where the area of the inlet is more and the area of the outlet is less. From the mass flow rate equation, we can say that the velocity of the inlet is low and the velocity of the outlet is high. Therefore, from the Bernoulli's theorem, where pressure is inversely proportional to velocity, we can say that the pressure at the inlet is higher and the pressure at the outlet is lower. The diffuser and nozzle are simple components with no moving parts in them. They can be used to change the velocity and flow at different sections of the engine to alter the pressure. And then we have the compressors and turbines, which have moving parts in them and are used to alter the pressure and temperature. So compressors reduce the volume as the fluid passes through it, therefore it increases the pressure and temperature at the end. And there are turbines which are completely opposite to them. They help in reducing the pressure and temperature by increasing the volume. With these basic concepts, we'll try to learn about the gas turbine engines. The development of gas turbine engines, also known as jet engine, began from the early 1930s. It was Frank Whittle who developed a suitable gas turbine engine for the aircrafts, and they came into existence from the 1939. These engines are capable of producing more power than a reciprocating engine. On an average, the current jet engines can produce up to 30,000 horsepower. Isn't that huge? Yes, it is. And there are different types of gas turbine engines. They are the turbojet engine, turboprop engine, turbofan engine, and a turboshaft engine. And there are other engines like the Ramjet and scramjet, which are not used by the aircrafts but are mostly used by launchers, which require initial thrust to power up the engine. A gas turbine engine is a heat engine which uses air as a working fluid. The working process would be similar to the 4-stroke reciprocating engine. The main difference is, in case of a reciprocating engine, combustion happens at a constant volume. Since the reciprocating engine contains a closed chamber where the volume is kept constant in case of combustion, whereas in a gas turbine engine, it happens at a constant pressure. Let us know how a turbojet engine works. It contains the following stages: the inlet duct or diffuser, compressor section, combustion chamber, turbine section, and then nozzle. The inlet. It is usually a divergent section, because of which the velocity of the air can be reduced and the pressure of the air can be slightly increased. It works with the principle of diffuser as discussed before. This air is then sent through a series of compressor blades where the volume is reduced. Due to the compression of air, it attains high pressure, which results in high temperature. Here, work is done on the compressor, which means we need to provide energy to compressor to do the work. And this high temperature gas coming from the compressor is then passed into the combustion chamber. In the combustion chamber, fuel is sprayed and then burnt. Hence, the temperature is increased furthermore in the combustion chamber. This results in an increase in volume at a constant pressure. Later in the turbine section, this gas is utilized to rotate the turbine blades. Since the volume of the gas is increased, this gas is then passed through the turbine section where the turbine blades rotate. It is an expansion process where volume is increased, which leads to a decrease in pressure and temperature. Here, work is done by the turbine. It means turbine produces the energy with the help of the fluid. This produced energy is transmitted through the turbine shaft, making it to rotate continuously. Since the energy produced is huge, the compressor is connected to the same shaft. Therefore, a part of the energy produced by the turbine is utilized by the compressor, and hence the compressor blades rotate. So once the engine gets started, it runs continuously with the supply of fuel. And the next stage includes emitting out the burnt gas from the nozzle. Nozzle is a converging section where the area is decreased. It helps in increasing the velocity at the outlet. So the exhaust gas needs to be emptied out at higher speeds to provide the thrust to the aircraft. Considering the Newton's third law, every action has an equal and opposite reaction. The high velocity exhaust gas pushes the aircraft forward in a turbojet engine. The other gas turbine engines have same working procedure with improved efficiency through their designs. So let's take a look at them. Turboprop engine. The name itself says the engine uses a propeller. A propeller is placed in front of the inlet of the engine, which is driven by the turbine shaft along with the compressor. It contains a reduction gearbox to control the speed of the propeller. In this engine, most of the energy produced by the turbine is utilized by the propeller. The remaining process would be similar to a turbojet engine. The turboprop engines are efficient below 800 km/h speeds and cannot be used at much higher speeds. Because of the effect of flow separation at the tip of the propeller blades, they cannot fly at higher speeds. But the advantage of turboprop over the turbojet engine is they can provide high initial thrust during takeoff and they can provide better fuel economy. These engines were mostly used in commercial and military aircrafts where high initial thrust is required to lift these heavy aircrafts. Then comes the most widely used aircraft engines in this era, the turbofan engine. Here, a fan is used in the beginning which draws more air into the engine. This fan is well protected by the cowling. Only some of the air drawn into the engine is passed through the high pressure compressor section, followed by combustion, and then the burnt gas passes through the high pressure turbine section followed by nozzle. So this is similar to a turbojet engine. So what's special about this engine? Here comes the most interesting part, the bypass section. Most of the air drawn inside the engine is diverted into the bypass region outside the compressor section. So this bypass air gets mixed with the exhaust gases at the end of the nozzle, thereby creating higher thrust at the exit. Even though the fan consumes a little more fuel, these engines provide more thrust than the other engines. So bypass ratio is the term used to distinguish the flow inside the engine. It is the ratio of mass of the air flowing through outer duct to the mass of the air flowing through the core of the engine. There are engines with bypass ratios of up to 12:1. It means for every 1 kg of air passing through the core of the engine, 12 kg of air passes through the outer duct of the engine. Most often, these engines are used by commercial aircrafts. The other type of gas turbine engine is a turboshaft engine. This engine is used in helicopters where directional change is required to transfer the power. It means, in case of helicopters, main rotor blades were placed above the fuselage section and the engine is placed below it. So, to transfer the power, a directional change is required where series of gears were used. The working is similar to a turbojet engine, but the turbine shaft is connected to the main rotor hub. Since the main rotor of the helicopter contains blades, they undergo stalling at higher speeds. Stalling refers to the condition where lift cannot be produced, so the speed of the main rotor hub is limited using the reduction gears. The other type of engines include the Ramjet, Scramjet, and Pulsejet engines. The Ramjet engine and the Scramjet engine doesn't have any moving parts in them, like in case of a normal turbojet engine. The shape of the engine is designed in such a way that they are capable of producing thrust at higher speeds without any moving parts in them. The main problem of using it in an aircraft is it requires an external source to provide the thrust initially. So these engines are mainly seen in launchers and missiles where external source is used to provide the initial thrust. And then we have the Pulsejet engine, which is a similar concept of Ramjet, but it can run from static condition with its design, which means it doesn't require any external source, but the Pulsejet engine consumes more fuel than the present gas turbine engines, so it is not used in aircraft power plants. I hope you have learned something new today. Thanks for watching. Please subscribe and keep supporting my channel for more interesting content in aviation.